Okay, we're going to do learning target 4 and 5 today. Again, the first half of this unit is mostly review, so I don't mean to be squeezing a bunch of things really quickly, but I don't think that it's that difficult to do. So you've done it all before, so we're going to go quickly through it now. All right, so the first thing we're going to do is learning target 4. And learning target 4 asks you to graph exponential functions or exponential inequalities. You guys have done this before with tables by hand and in your calculator. I know you're going to use your calculator, and that's completely fine. But what I do today, I just want to make sure you remember what everything means, and we can talk about some things with domain and range. I have a note sheet in front of you with 3 graphs, the same 3 I have up here, but I'm only going to do number 7, this inequality, because if you can graph the inequality, then you can graph the equation, because the equation is just the curve without any shading or worrying about solid and dotted, that kind of thing. Okay? So if I want to graph the inequality y is greater than 2 to the x minus 4, I'm going to graph y equals first. So if you make a table of values, you want to choose some negatives, some positives, and you're going to fill their x values in with those. So we'd have 2 to the negative second minus 4, 2 to the negative first minus 4, and so on and so forth. But it's important to remember what all these exponents mean. So 2 to the negative second power is not negative 4. So don't do that. That's a common mistake. But 2 to the negative second power is 1 over 2 to the second, or 1 over 4. And so 1/4 minus 4 is negative 3.75. So in the same vein, 2 to the negative first is 1/2. So you get negative 3.5. 2 to the 0 is not 0. Another common mistake. 2 to the 0 is 1. And so we have a table of values, and we have x, y's, and we're going to be able to graph these. Okay? So that's what we're going to do really quickly. All right, so we can see that it's definitely a curve. All right, but we need to talk about the domain and range real fast. I know that the right side of this graph is increasing, but what's happening on the left-hand side of this graph? All right, if you look into your calculator and we type this in, then you would see that if you keep getting more negative values, if you added in like x, and you had x as negative 3 and negative 4, negative 5, you keep getting fractions, and so a fraction minus 4 is still negative 3 point something, and so you keep getting these numbers that are closer and closer to negative 4, but they never actually cross negative 4. So an exponential function kind of evens itself out, right? It's not a straight line, okay? Now, this is actually an inequality. And it says that we have y is greater than 2 to the x minus 4. So this actually needs to be a dotted curve or dash curve showing that it cannot be equal to. And then we have to go through and worry about the shading. It says y is greater than, but if you get stumped about what that means, you can always use a test point. So I'll use a test point of 0, 0. So is 0 greater than 2 to the 0 minus 4? Well, 2 to the 0 minus 4 is negative 3, and 0 is greater than negative 3. So I'm going to shade the part of my curve that contains the 0, 0. So we just finished doing inequalities with conic sections, kind of reminded you some of those rules. Same rules apply here for exponentials. If you have greater than or less than, you have a dash or dotted line, and greater than or equal to, less than or equal to, you have a solid line. And you can need to shade in the side that makes the inequality statement true. Okay? That's learning target 4. Learning target 4 homework has graphs for you to do of equations and inequalities. It's just practice. Again, you can graph the actual curve using your calculator if you need to. Now, learning target 5 is about using exponential functions to solve growth and decay problems. All right? So growth or decay problems are word problems, and you're given this equation, and I will provide this equation to you. Okay? but you need to know what everything stands for. So N is the final amount. N naught is the initial amount, so what you start with. R is the rate of growth or decay. Here's some notes about R. R is going to be given to you as a percent. You need to write the percent in decimal form in this equation. If R is representing growth, then it's going to be positive. If it's representing decay, it's going to be negative. Okay? And then T is the number of time periods. That could be years, days, weeks, months, minutes, seconds, whatever time period you want to use. A special type of problem is a compound interest problem. That's mostly when you have money, and it's going to say that it's being compounded. You have an exponential growth, but it has a certain amount of times it's being compounded each year, so it becomes a little more tricky with this equation. So again, P is the initial investment or your starting amount, and A is the final amount. R is still a rate, still needs to be written as the percent in decimal form. N is the number of times interest is paid per year. So for example, if it says it was compounded quarterly, that means that's 4 times a year, so N equals 4. If it says compounded monthly, that's 12 times a year, so N is 12. Right? That's how that works. And then very important, T is still time, but T has to be in years or this doesn't work. Okay? So 2 examples. Business owners keep track of the value of their assets for tax purposes. Suppose the value of a computer depreciates at a rate of 25% a year. Determine the value of a laptop computer 2 years after it's been purchased for $3,750. Well, okay, we know this is going to be a growth or decay question. So it's not talking about interest on an account or anything, not about compounding anywhere. The word depreciates indicates it's going to be a decay problem. So here's our equation. We're looking for the final value of the laptop. So the initial value of the laptop is $3,750. Our rate of depreciation is 25% a year, and it's decay, it's negative 0.25. And we're talking about 2 years after it's been purchased, so the time is 2. So in your calculator, get mine real fast. I have 0.75 squared times 3750. I need $2,109.38. Okay? Not so bad. You're using the formulas. The other question is a finance question. Determine the amount of money in a money market account providing an annual rate of 5% compounded daily if Marcus invested $2,000 and left it in the account for 7 years. Well, it says the word compounded, so we're using the compound interest equation. So we're looking for that final amount in the account. We invested $2,000, Marcus did. My annual rate of interest is 5%. Make sure that's 0.05, not 0.5. And it says it's compounded daily. So if it's compounded daily, that's 365 days a year. And then times the amount of years, T, which is 7. Be very careful when you're typing these into your calculator. These can easily go wrong. So 0.05 divided by 365 plus 1 raised to the 365 times 7 power times 2,000, $2,838.07. So he made about $838.07 in that 7 years. Not too bad. Right? That's learning target 5. So learning target 4 and 5 are things that are not difficult. 4, you definitely did in Algebra 2. I taught exponential growth in Algebra 1, so these things you have seen before. You can do learning target 4 and 5 assignments, and if you have questions, please ask me.